Hello again, young people. Part 3, internal and external energy. This is pretty simple, but it's an important concept. We live on the surface of the earth. We don't live high in the atmosphere, and we don't live deep underground. We live right at the surface. And the surface is actually a pretty tough boundary for energy in the Earth system, the big Earth system. And there's sort of two main areas that lots and lots of energy exists, and they don't overlap very much. There is energy at the surface and in the atmosphere. We consider the water and the oceans to be at the surface. Over 99.9% of that energy comes from solar radiation. It comes from the sun. But there's also tons and tons of heat. That little 0.01% of energy that doesn't come from the sun at the surface, you might think like hot springs. Hot springs are water that comes out of the ground and it's warmed by heat inside the earth. That's not from the sun. And there's a lot of heat inside the planet. There's a lot of energy inside the earth. And that energy inside the earth, it's basically, there's two big categories. There is heat that is left over from the formation of our earth. More about that in a couple of videos. And there's heat from radioactive decay. More about that in a couple of videos too. But the thing is, all that internal energy is more or less isolated. It moves by both convection and conduction through our planet, from the core to the mantle to the crust of the earth. You remember that from junior high, right? Core, mantle, crust. When we talk about the core and mantle and crust of the earth, we break it down in those three categories based on composition. The crust of the earth is made of different stuff than the mantle, which is made of different stuff than the core. Geologists, however, sometimes and often find it more useful to talk about the earth in terms of the lithosphere, the asthenosphere, the outer core and the inner core. And those differentiations are based not on composition, but on physical properties. And a big part of those physical properties is how energy transfers. The inner core is solid. It is solid metal, solid iron, and a little bit of nickel. Energy in the inner core transfers by conduction, from just touching. The outer core is liquid. It's still the core, so it's still iron, but it's liquid iron. In a liquid, energy is going to transfer by conduction, but it's also going to transfer by convection. The same goes for the mantle or the asthenosphere. The lithosphere, the outer layer, mainly transfers by conduction. But most of that energy stays inside the earth. It's more or less locked in there. But every now and then, some of it escapes. And, you get a slow dribble from places with hot springs. But whenever there's a volcanic eruption, it's a big event transferring matter and energy from internal matter and energy to external, to the surface of the earth, and the spheres, the biosphere, the geosphere, the hydrosphere, the atmosphere. Okay, that's it for that one. Next up, external energy.